Okay. So, coming back to this, therefore, we can cut down onto the curing water by using curing compound, which are nothing but surface layer. What happens is they block the evaporation process, do not allow water to evaporate, which is a major component of loss of water, but do not supplement. So, you have to actually design the system. As I said, there are two types, resin based and then wax based, right, and these are some kind of other resin based, these are commercially available now. Now, there would be, they will, you can check them or compare them. If you compare this curing terms of compressive strength 28 days, it would be somewhat less, strength would be somewhat less, but you are saving onto water. So, you might have to use a little bit of more cement in the system, water cement ratio has to be appropriate. So, you have to see which one benefits you more, right, because 85% strength you will not get the same, because self desiccation water is not being replenished, right, self desiccation water is not replenished. Water absorption of concrete with resin based is 10 to 15% more with respect to tap water curing, right, and wax based compound provides surface hardness about, because but then make the surface very good, because locally the water cement ratio, they actually this that part no water will tend to evaporate out, but then it is stuck at the this is contained at the boundary of itself, but this is already after setting. So, the overall water cement ratio change or structure change is not occurring. So, generally surface is improved significantly if you use this kind of treatment. There is one thing one must see, these are something like these are addition, these are the kind of material which you see. Now, there is one more thing you should see. See, when you are using this, you must see that it is able to withstand the ambient temperature. For example, summer time in climates of the tropical climates, say even in climate of the kind of Delhi, which is called composite monsoon climate, we have some time of the year absolutely dry, then you have got some time of the year when you have rainfall, and then winter. So, during the dry period the temperature goes up to about 40-45 degrees centigrade, and if radiation is falling onto it, the surface, it might increase this by another 15 degrees centigrade, because direct radiation means direct energy coming in. So, if you touch the surface, it will be hotter than the air temperature. Now, under such situation, these compounds must be stable. Wax melt away, wax can melt away, simply peel away from the surface if it is exposed to sunlight and hot air. So, May, June if one is doing, one has to be careful, and in climates, for example, in desert one has to be careful, but then desert water is not available. So, you have to design the system appropriately, choose the right kind of compound appropriately, right. So, treated domestic effluent gives you another advantage, that is a reuse of the water that is available, right. So, for concrete mixing and curing both you can use this, treated domestic you can use this both. So, the point is, the earlier point is that if you use curing compound or similar kind of thing, there is some other kind of curing aspect I will talk about, because you can have admixtures which you add to the concrete and they can store the water, right. So, whatever water you have given, they will absorb and release it later on. So, this is another kind of admixtures, curing admixtures you can use to cure, we will come to that later on, but this will be very useful. Treated domestic water, because otherwise you would have actually put it into the river after treatment also. Here it can be used for construction purposes. Now, okay, for example, if you collect from STP, right, treatment plant, sewage treatment plant, so you collect from there, then you have to test them for the, because drinking water, potable water is not necessary for concreting. Human body gets affected by bacteria, the small quantity of bacteria do not affect the concrete, but concrete is affected by this SO3 right, okay, or the SO3, SO4, etc., or particulate matter, suspended particulate matter, and these are given in standard, whether you take American Society of Testing Material, Indian standard, or any standard, you will get this standard. So, first you have to test whether they satisfy those requirements or not, right. So, so you just test them. If you test them and just a comparison in a particular case, for example, this is in this is parameters of total solids, suspended matter, as I just said, inorganic solid, organic solid, pH. Okay. So, these are all in milligrams per liter as shown. This is an example, similar things could be there elsewhere. Total alkalinity, total acidity, chloride concentration, sulphate concentration, and this must be total solid should be there is a limit available as far as ASTM is concerned. This is just as an example, but that is not important. So, STS limit is something like 50,000 milligrams per liter, it should be less than that. Similarly, if you come to Indian standard, it gives you suspended matter, inorganic solid, organic solid, pH should be greater than 6, should be but should not be too alkaline, right, too alkaline, cannot be acidic, because cement reaction produces alkaline material and it should not interfere with the reaction process. So, this is as far as Indian standard is concerned, this value is given 6 to 8, and total alkalinity. Now, chloride content is given by IS 456, BSEN, ASTM, everybody gives this chloride, and this quantity 500 milligram per liter is one of the limits actually. So, you will find ASTM 6, ASTM C1602, BSEN or EN 1008, IS 456 of course gives you. So, you have to see whatever limits you are, whatever code you are using, it must satisfy. Okay. Right. Similarly, sulphate are the other one. So, sulphate are the other ones, and these values are again given, they are not all same, different codes have different values. So, it must satisfy this requirement, and once this satisfied, test has been done, then for example, one can, this is manually collected scenario, and one can collect this. So, standards, this the ASTM as I said 1602, BSEN 1008 and Indian standard 456. So, this is European, this is American and Indian. So, you can look into this and they must satisfy this. Once they satisfy this, you can get sometimes better compressive strength, right, and water imperviousness also at the surface with respect to some local tap water curing. So, higher if we, higher strength gain could be somewhat even higher, better strength for concrete skin. If one tests them through various kind of testing, it is possible to test only the skin performance through something like surface hardness tests, cutting what you call doing what is called a capo test at the surface, cut and pull out test. So, there are various tests available. You can actually find out the property of surface concrete, while your standard specimen is cube specimen. Cube test might be similar, cube strength must be similar, but surface concrete you find that might be, it is what is important from durability. So, that is what it is, and then you can find, this is one example empirical result. Somebody might say no, this is not there, but it would be within not large variation. That means, what we are trying to point out is that treated domestic waste you can always use, treated effluent you can use actually from collected from STP you can use. So, right. So, this is what it is, treated domestic effluent and 90 days strength etc., are better. So, this is one case. Okay. So, water penetration or all other properties, if you look at it, concrete, you might find better. This is what is called a Capo test, cut from the surface, right. And if you look at it, water cement ratio, mixing water, this gives an example. This is ultrasound pulse velocity is, velocity is of sound in mechanical, velocity of mechanical waves is proportional to under root E by rho. Velocity of mechanical wave in a solid media is proportional to bulk modulus divided by density, right. In fact, the formula is straightforward, but I do not think I need to go into how, because when mechanical wave travels in a solid medium, there is compression and rarefaction. Therefore, that would be related to the stress, the strain. So, sound pressure or mechanical wave pressure, the stress, deformation is strain. So, it gets related to bulk modulus, and it is related to density because acceleration is mass, force is pressure is also. So, velocity, half rho v square will be the energy. So, anyway, I am not going into this, So, basically velocity is a function of, so denser the material, more is the velocity, less is the E over rho, bulk modulus is more, velocity is higher. So, ultrasonic pulse velocity we do not use within sonic range, we use ultrasonic, right, because of the dimensional issues, wavelength issues actually. Velocity of mechanical wave in concrete would be of the order around 4500 meter per second, and dimensions of the specimens So, at least one wavelength must be contained within the aggregate, largest aggregate, and also there should not be all other phenomena occurring, diffraction and such phenomena. So, therefore, dimensions, this ultrasonic suits pretty well from that point of view, other than creating noise. Ultrasonic will not create noise. So, ultrasonic pulse velocity is a measure of solidness of the concrete. If it is more solid, you will have higher velocity, right. So, this is what it is. So, if you can see that mixing water, this is treated water, treated effluent, treated water, So, these diagrams are different. 0.4 treated water, treated effluent, treated water. So, they are comparable. Ultrasonic pulse velocity is comparable. This is for effluent, this is one of this for effluent, another is for treated water. This is for effluent, this is for water. So, they are comparable. Similarly, strengths are not very significantly lower, just comparable. So, all these properties that you see, they are comparable to comparable properties for treated effluent or treated water, because tap water would be quite often treated, and similarly various other properties like initial surface absorption test, that is a measure for durability, and you will find that the treated domestic effluent do not give you worse result. Only one thing you see, there are different process of treatment. The one which has got H2S, there are different process, the process should not have toxic gases or not toxic really, gases or material content which are toxic to concrete system. For example, if you have H2S present in the treated water, making it sulfuric acid or something, such thing should not be there. Therefore, you can use treated domestic effluent as long as they satisfy the standards requirement, water requirement, standard water requirement. Bacteria is not an issue, total organic content is an issue. All right. So, this was related to use of treated water. That way you can reduce down cut down onto the water. You can cut down on the water consumption both for curing as well as mixing. One approach is to use the curing compound at the surface, that will cut down onto your curing water. Superplasticizer, plasticizer, hyperplasticizer, water reducing agents, that will cut down into your water, can cut down onto your cement also. The third approach is use treated domestic effluent as long as the water quality satisfy the requirement of standard codes, they do not seem to create any problem. So, you have choices of using all of them, whichever is appropriate. Now, there are, as I said, there are self curing compound, that is, you add to the concrete right in the beginning, they will hold on to the water, and later on they will release them. So, there are two types essentially. One is super absorbent polymer. These are used for hygienic and medical uses also. So, what they do is they absorb water. So, during the initial phase, they will absorb the water, mixing part of the mixing water. Now, therefore, water cement ratio gets reduced during the setting phase. Setting means solidification. The structure of the concrete or cement based system forms right at the setting stage, right, because structure will be formed there. After that, the only what happens is the unoccupied space which was not occupied by solid, fine space I am talking of, because aggregate space, aggregates are stable, nothing will happen to them. Cement hydrates and the space which was earlier occupied by water or unoccupied space, that get filled in. So, setting means solidification. Once it has become solid, no more expansion of the solid will occur actually. What will happen is it may contract a little bit, shrinkage can occur. So, setting is important. During setting phase, this super absorbent polymer absorbs water, keeps it with themselves, right. So, water cement ratio to start with is less than what you have added, because polymer should have absorbed some of this. And then as the water reacts with cement system, the vapor pressure would reduce there. There will be vapor pressure gradient existing between the polymer, absorbent polymer and the remaining portion, it will release the water gradually. So, this super absorbent polymer is one of those admixtures which can be added to the cement based system or concrete system to reduce down the curing water. So, that you have added right in the beginning, later on you may do or may not do. So, these are copolymer of or acrylamide and acrylate units. Finally, divided particulate material, they are generally spherical in dry state, 45 to 850 microns in diameter, would look something like this, right. And there is other types are there, polyethylene glycol, this is another one. So, this also does same thing, it holds on the water and releases later on. So, this you add to the concrete system, right in the beginning time of mixing, and this is a creamy white flaky particle like this, where grounded to less than 1.17 millimeter size and dissolved in mixing water prior to application. So, you just dissolve the aerated that, and that too will not do the job as good as possibly water curing, but definitely do a sufficiently good job to cut down onto your water use. So, increasing SAP doses results in stiffening of cement paste and hence increase water demand. Sometimes some of those sap, that is super absorbing polymer, absorbs too much of water. So, that will disturb the setting process, stiffens it quickly, right. So, cement paste and hence initial water demand might increase for a given consistency. Polyethylene glycol does not have any effect of this one, right. Initial and final setting time increase with increasing SAP and PEG. So, initial setting time increases a little bit, right, which means that solidification process is delayed. Solidification process is delayed a little bit. Now, what is the difference between initial setting and final setting? Initial setting is when it has achieved such a state that if you disturb it anymore, then its properties would be damaged. So, it has not fully solidified, but formed a solid structure, right, formed a solid structure from the plastic state that it was. And final setting means it has become a stable solid with a definite shape and, well, by and large the volume as well, because there can be some contraction, so that you can remove the side support side shattering, side formwork you can remove. So, final setting is that. Now, usually cements will have setting time minimum is specified is 30 minutes, because you want to work compact, put it into the mold and compact it within that period of time. So, it is specified that minimum. If I have 100 minutes, does not matter, right. I will have more time to actually compact and place it, but 30 minutes is the minimum for all cements. And final setting time, when I should be able to remove the side formwork, that is 10 hours, right. So, my setting time should be more than, initial setting time should be more than this, and this should be less than this. Most of the cements, what you will find is, this is much higher, go to even 90 minutes, 1 hour or so, and this should be about 3 to 4 hours, not even 10 hours. Now, these are measured by some empirical test called Vickers test, actually Vickers apparatus. I think I will not go into that, but or by penetration resistance test, etc., etc. Now, what does this do? This increases the initial setting time. So, if it was about 45-50 minutes, now it will go to 90 minutes, I have no problem. It increases the final setting time. As long as that final setting time is not more than 10 hours, I have no problem. Many of the cements will have 3 to 4 hours. So, let it increase a little bit, but you have to check that it does not increase beyond 10 hours, then you will have issues of demolding. So, these are the effects of, but these materials you can use them, right. So, these are some of those results, SAP doses, super absorbent polymer doses, So, this is what you call initial and final setting time in minutes, right. Standard consistency is what is measured, I mean, and then you add them and same amount of water and you find out, right. So, this is what it is. So, initial setting time, final setting time, this is what is given here. As I increase the dosage, SAP dosage to 1% or so, this is also small quantity. So, this is what happens, and this is with polyethylene glycol, right. So, this is the dosage it shows, and these are the properties, how it will go, and that is what it is, right. Compressive strength of mortar specimen increase with SAP doses, SAP action become eminent 3 days of curing age, higher SAP doses with finer size is expected to perform better. Okay, that is all right. So, compressive strength, there is no effect really, that is what we are saying. And PEG does not, in low proportions of cement, resulted in strength and water tightness comparable to water cured samples. For higher dosage at later ages, loss of strength is recorded. So, you have to be careful. So, you have to know that there can be PEG can cause loss of strength as well. In other words, one has to verify these materials before using them. So, you need an engineered material design system, where in the laboratory you will first test them and then make sure that things are all right, then only you will do it. So, you can see that strength increases, there is a reduction, strength, different water cement ratio we are talking about, strength increases and there is reduction at, of course, this is 7 days, this is 3 days, right. So, this is PEG doses, different water cement ratio. This is high water cement ratio. In high water cement ratio, there is no problem. In the lower water cement ratio, in this reduction is observed. So, they are you can use them, but after proper verification. The maximum dosage of SAP, of course, could be of the order of 0.32% for subsequent, so you can optimize them, find out what is the best. Minimum and maximum doses of acceptable performance in consistency, mortar, etc. You can first you should find out. A molality of 0.44 was the upper limit of PEG concentration we are talking of. SAP doses of 0.16 were used, okay, it is all right. So, some more results are available. If you look at calorimetry, which you use to find out heat of hydration and all that, that would tell us. So, the heat of hydration for various cases, so exhibits same trend, but okay, it does cause improvement in degree of hydration in relation to water. So, calorimetry gives you idea related to degree of hydration, because heat release. So, heat release rate, if you see various cases it is showing. So, the trend is similar, and degree of hydration improves a little bit with this kind of material. Similarly, moisture transport, if you look at it, because durability issues are there. So, higher SEP doses lead to better water retention, and mortar specimen efficiency is better, okay, lower water cement ratios. PEG low amount improves water retention in low water high doses, that means same thing, strength we have seen. So, dosage has to be optimized. Water absorption reduced with age with higher doses of PEG indicating densification. For mixes incorporating SEP, water absorption results were not truly indicative of open porosity owing to the dehydration, okay, etc. So, the point that for your class what we would mention is, I would suggest is essentially that these materials are available, super absorbent polymers or PEGs, which are curing admixtures. You got to use them, as we said, the dosage has to be optimized, all properties has to be checked before using, because this has not come to such a level that you can use it without. So, it has to be an engineered concrete. That is why I was talking about N component of concrete, not 4, N component. So, cement, water, coarse aggregate, fine aggregate, X1, X2, etc. different varieties of admixtures are possible, and you have to design the system for sustainability and for your performance that you require, right. Okay. pH of the mix do not change, because that has something to do with durability, least initial absorption, etc. So, durability, some durability properties shows proper improvement. Improvement in strength for lower water cement ratio 7 days, beyond that it reduces. The cause for this effect relates to quantity of water available in SEP particles mixed. A greater quantity of water per unit mass of the admixed SEP leads to formation of larger voids. Okay, these are details, but I think I have made my point already, that incorporation some loss of strength in the long run. PEG, okay, the structures, one can look into the microstructures and things like that. So, there is a possibility of using all those. If you see the economics part of it, then one can find out the cost, because this itself has got some amount of cost implication. Total cost of concrete one can calculate out for the similar strength of concrete, right. So, if you see that, you will find out you have taken a practical concrete used in Kochi Metro. There is a self curing, there is a cost increases significantly. So, it was per meter, total cost per meter cube, there is a self curing, there is a cost increase is very much there. So, amount of excess cement required to lower water cement ratio, if you want to get the same strength. So, cost of cement will also increase. So, you have to see what is more important here, curing admixtures if you are using, the cost particular case that we looked into for Kochi Metro, let us say, because I want to get the same strength, lower water cement ratio, strength gets reduced. So, I might use more cement and the cost increases with this kind of material, for the same strength cost increases. So, you have to see the economics part of it if you are using this, but these options remain, and possibly more research would show that possibly economically one can use these admixtures. They have their advantages. Where water is absolutely scarce, one might try to use them. Where water scarcity is not so much, rather the problem is the cost of cement will increase if you want to get high strength system. In low strength system still you can use this. So, if you see the different construction of precast concrete, right, energy and carbon dioxide from concrete system, I think we will look into this in the next class. River and metal, just quantity of carbon dioxide, that is what comes to. So, from production process we will look into this in the next class. We will look into, so this at this stage I think we will stop here, and if you have any questions we would like to answer them.